Got to be my eyes on my camera a minute, so we're going live, and we are now live. All right. Broadcasting to the internet. Yeah, it's warming up. It's coming on. All right. So today is going to be a fun day. You guys hate it when I say that, right? Okay. So we are going to find, well, here, I'll give you a preview. 3.4 is going to find the real zeros. And 3.5 is going to say find all the zeros. So these are good. So we're not going to worry about whether they're real or not. We're going to do the imaginary numbers too, okay? So essentially, we're going to find all the zeros, whether they're real or not, okay? Now, the way we're going to do that is with a couple of awesome theorems here. One is called Irrational Zeros theorem. Okay? And it works whether they're real or imaginary. Okay? And so the idea here is if I have some polynomial function of x such that I've got, and I don't really like this, a1, a to the n, x to the n, plus a n minus 1, x to the n minus 1, etc., all the way until I get down to a to the a1 of x plus some constant term, a sub 0, okay? Then, and we are assuming all of the a's are integers. Okay, so we're not going to have 3.2x squared or something like that. Okay, we're assuming all of these terms here are integers. Okay, then P is a factor of a sub 0 and q, which is the constant term, and q is a factor of the leading coefficient, a sub n. Okay? Essentially what this means is that all possible factors are a combination of P divided by Q. Okay? So that's essentially the rational zeros theorem. So what does that mean in practice? Okay, let's do an example here. Let's say, for example, I have p of x equals 2x cubed minus x squared plus 13x plus 6. And let's say that I want you to find all possible factors. Or maybe I'll say just zeros. I'm going to say zeros. I don't want to say factors. Find all possible zeros. Okay? Now, how many answers am I going to have? How many zeros am I going to have as a maximum? You're going to have 3 zeros, and that's because of this here. Okay? So I'm going to have a maximum of 3 zeros. Okay? Now the problem is finding those zeros can be a little bit tricky, right? We don't have any nice factoring techniques yet to factor this, right? Okay? So according to the rational zeros theorem is what I can do is I can say, okay, find your P's and your Q's. Okay? So what this will do is it will help me eliminate some of these options. Okay, so what are all the possible factors of 6? So 1, 2, 3, and 6. And I put plus or minus on there, right? 2 times 3 is 6, 1 times 6 is 6. So those are all the possible factors of 6. Okay? What are all the possible factors of the leading term 2? 1 and 2. Okay? So according to the rational zeros theorem, okay, I'm going to have a maximum of 3 zeros, but now I know, for example, 4 is not a factor of this. And I know that 5 is not a possible factor. And I actually know that 0 is not a possible factor. Okay? So all the possible factors are all the combinations of p divided by q. So the easiest thing to do is to take all of these and divide them by 1, right? So the possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay? And then, so that's all of these divided by 1. Now we're going to do the same thing, and we're going to do all of these divided by 2. So I've also got plus or minus 1/2. Okay, 1/2. 2 halves is 1, so I don't need to relist it. 3 halves. And 6 halves is 3, so I don't need to list it. Okay? So if I ask you, what are all the possible zeros? I'm looking for 1, 2, 3, 4, 5, 6, technically 12 because they're plus or minus. Okay? So the idea here is we can use the rational zeros theorem so that I don't say, hey, I wonder if 4 is a factor. I can already tell you 4 is not a factor. 4 will not work. Okay? Does that make sense? 5 will not work. Okay? So the idea with the rational zeros theorem combined with synthetic division is I'm going to have an idea of what the possible factors might be. Okay? So this is going to help me reduce from an infinite number of possible factors to, I've only got 12 to test. Okay? Does that make sense? Now, would you like to narrow it down even more? Yes.
Good question.
Okay.
So I'm reading through the definition. So Q is a factor of, what is that?
Q is a factor of the leading coefficient here. So these are, this is the Q's, these are the P's. Okay. Now, of course, we are assuming that that's not a 0 and that's not a 0. Okay. Clearly, those can't be 0. But it does mention that. I didn't write that on the board. So a sub n cannot equal 0 and a sub 0 cannot equal 0. Okay.
So
Does that make sense? Okay. So the idea here is with the rational zeros theorem, we're going to narrow down our choices. Now, let me show you another thing. And I don't know how helpful this is. It's kind of helpful. But we have a thing called Descartes' rule of signs. Okay. All right. So you notice that I've got plus or minus here. It would be nice to be able to decide if they were positive or negative, correct? Okay. So here's where Descartes' rule of signs. The number of positive real zeros is equal to the number of variations in sign in P of X or less than pi and even whole number. I know that's a little confusing, and I'm going to explain it in just a minute, okay? Let me say here, the number of negative, so I'll underline that. These are positive 10, number one, negative down here. Negative real zeros is equal to the number of variations in sign of p of negative x or less by an even whole number.
The camera's not on.
Oh, the camera's not on that, thank you. Okay. All right. So here's what that means. Okay. Now let's go back to my polynomial function. Okay, my original polynomial function here. We're going to apply Descartes' rule of signs to this function right here. Okay. You can see here that we have a positive 2, right? And then we have a negative 1 here, right? So we've changed signs from positive to negative. That's one change in signs, okay? Then we go from negative to positive. That's two changes in sign. Then we go from positive to positive. So that's not a change in sign, correct? Okay? So essentially what we're saying here with the Descartes' rule of signs is I'm going to have at most 2 or 0 positive roots. Okay? Now, why would I not have only one positive root? Okay? If you think about this, what's the power function? Y equals x cubed, right? So it could look something like this, right? I don't know what it looks like, but it could look something like that, okay? So the way I've drawn it, well, actually I drew it wrong. According to Descartes' rule of signs, let me try this again, okay? Okay? According to Descartes' rule of signs, that first graph that I drew, it couldn't have been. In this case, I've got 2 positive roots, and I have 1 negative, or 2 positive zeros and 1 negative 0. Okay? So this will help me because if I get 2 positive values, let's say that x minus 2 and x minus 3 are factors, and I don't know if they are, but let's pretend they are. Then I'm going to have a positive root, a positive 0 at 2 and at 3. I know not to pick any more positive numbers, they can only be negative. Okay? Now, let's do the same thing. I think this is an easy rule. This one's kind of a pain in the butt, and I don't worry about it too much. Okay? So the number of negative real zeros, now I'm going to find p of minus x. Okay, so p of minus x is going to be 2 times minus x cubed minus x squared plus 13 times minus x plus 6. To me, rule number 2 is just too much work. Okay? In fact, I could already tell you, if I have 2 positive real zeros, how many negative real zeros am I going to have at most? I'm going to have 1, or I could have 2 or 0, right? Okay? But at any rate, we're going to finish the rule of signs just so you understand what it means. Okay? Negative x cubed is negative x cubed. So this becomes negative 2x cubed, right? Negative squared is Positive times a negative is a negative, x squared, okay? Minus 13x plus 6, right? So essentially, we're going to use rule number 2 here with Descartes' rule of signs, okay? Do I have a change in sign here? No. Change in sign? No. Change in sign? Yes, okay? So, at most, I will have 1, negative, 0. Okay? So I know I'm going to have at most 2 positive and at most 1 negative. I could have none of the above, although this is a cubic function, so I'm at least going to have 1, 0, correct? It might look something like that, so I will have 1 negative, or it could have 1 positive, or it could have something like this, but it will not look like that. Right? This gives me 3 negatives. Ain't no way that's possible. Okay? Does that make sense? So there's no way this is going to happen. Yes?
Did you know just by looking at it, there was only 1 negative?
How did I know?
Yeah, you said it was
Because I said,
positive.
because with this, I knew that there were 2, at most 2, and I only got 3 roots. So at most, I can only have 1 negative. Okay? Does that make sense? Okay? All right, so now, can I erase this rational zeros theorem? Because I need more. Okay? All right, so I'm going to erase this. And we're going to show you how to factor this. Okay? We'll do this exact one. But we know here all of the numbers that we should pick. Okay? All of my possible zeros. Okay? So out of all those possible zeros and synthetic division, which one do you want to pick first? Do you know?
Out of all the numbers?
Out of all my possible zeros, which one do you want to pick first? I usually try to pick the easy ones first. 1, that's a good number to pick first, okay? We're going to try to find out if positive 1 is a factor of this polynomial function. So tell me what to write to do synthetic division here.
2.
2,
Negative 1.
-1,
13.
13, and 6. Okay? All right. I'll give you another rule in a minute here. We'll see if it applies to this. Can you help me do synthetic division?
2.
2, 2, 1, 1, 14, 14, and 20. Is 1 a 0 of this? No, because this is not 0. Who might be the next easy one to try? -1. Thank you, Jackson. So let's just try -1 right now. Okay. Let's try -1. Okay. Do you want to take it away?
Sure. Bring down 2, multiply by 2, -1, or -2, sorry.
-2.
Add them together, -3,
We go
multiply
3,
3,
3,
16,
16.
-16, -10, not a 0.
Okay, so now I have eliminated positive and -1 as a possible 0. It's no longer a 0. Okay, what do you want to try next?
3.
3? Okay, we're going to try 3. How about Christian?
Pull 2 down.
2,
It's going to be 6.
6,
So 5,
5,
15,
15,
28,
28.
and then
Big number, it's not going to work, right? Okay, how about, what do you want to try next?
-3.
-3. Let's see if we can eliminate that altogether. Okay? So we'll ask Mallory to do it. No, Mallory in the back, I see you.
2 down, -6, -7, +21, 34.
And a big negative number, is that one gonna work? Okay, so we've now eliminated this. What, I'll let Mallory pick. What do you want to try next?
2.
2. Let's try 2. Let's pick on Hunter.
Okay, bring down the 2, and then that becomes 4, that becomes 3, and then 6, that's 19, and then
38 is not going to work, right? Let's try now what?
negative.
-2. Okay. Let's pick on Sam.
So you bring down the 2, you're gonna get -4, which would be 5. Or -5, yeah. You're gonna get -10.
+10.
Right.
Don't mess up
yeah.
your signs now. Yep.
23,
23.
you're gonna get -46.
Yeah, whatever. It's not going to work, right? So we've eliminated the 2's, right? Okay. One half. Okay, let's try half. So, vertically or negatively?
Bring down to
2 times a half. 1.
and then 0,
0.
and then 0,
0.
and then 13, and then
2 halves is not going to work. Try -1/2. And I hope this one has roots. I didn't even look. I just figured they wouldn't start with a bad one, would they? They could. We'll see. Okay, -1/2. Angel.
So bring down 2, that'll be -1, and -2, and that'll be +1, 13.
14.
14, sorry, and then that is -7.
Oh, that was close. Okay. Are we going to strike out on this one? We got to get at least one of them, right? There's got to be at least one root. Okay, so we've tried +and -1/2. Well, we've only got 4 more to go. Julia, it must be your turn. Which one do you want to pick? 6. Okay.
Okay, so you bring down 2, 12, 11, 66, 79.
Ain't gonna work, right? So the -6. Whose turn is it now? It must be Jonathan's turn.
Reading 2 down, I'm making -12, which is -15.
6 times 13, 8. 6 times 18, 78, and it's positive. Ain't gonna work, right? Okay. Well, we're down to two choices. It's gotta be one of these two, right? Because we've gotta have at least one root. Usually we don't strike out this badly, especially on the first trouble. Good practice. This is good practice for synthetic division. Bailey, it must be your turn. One's your positive or negative?
Let's do negative.
-3 halves.
Alright, so bring down the 2, and then
2's cancel on with -3.
4.
4 of the 2 cancel. That becomes 2 times 3 is +6, right? Negative times negative is positive. 19. That's not going to work. +3 halves. Wow.
Well,
It's got to work this time, right?
at this point, what we know it couldn't work because we can't have one positive.
We can have at most. Oh. One of these has to work. Did we make a mistake somewhere?
It's impossible. Did you write down?
Here, what is finish it? Did I write it down?
Just write synthetic division process.
Yeah.
You got it down there? And you got this one.
Oh, we made some mistakes then. Unless I wrote the problem down wrong. 2x squared. Oh, I wrote the problem down wrong. That would help. Okay, here, I'll tell you what, we'll write the problem down right this time. 2x cubed plus x squared minus 13x plus 6. Okay? And just for fun, let's try 2 this time. Niels, can you take it away?
Perfect, bring down the 2.
Positive 1.
4.
That's positive 1.
3.
Oh, actually, yeah, we didn't change that, did we? We wrote the problem down right. So 2, positive 1, minus 13, and 6. Let's try that again. Now it'll work.
Okay, we'll still bring down the 2.
2,
Times 2 is 4. Add 1, 5. Times 2 is 10. You get a negative 3. Times 2, negative 6. And you get 0.
finally. Okay, it only helps if you write the problem down. Okay, all right. So this becomes now what? What is this?
Our leading coefficient on
This
x
is 2x squared, right?
Yeah, and then plus
Plus 5x minus 3. Okay. Now, okay. So what's the factor here?
It would have to be x minus 2.
X minus 2. Now, can we factor that without going through all that rigmarole?
Sure.
Yes. Now we've got a positive, so there's got to be a positive and a negative here, right? I think. Factors are 2x, x, 3, 1. Which one's positive and negative? Positive 3 minus 1, right? Okay. So your zeros are at 2, 1/2, and negative 3. 2 positive, 1 negative.
So you just need to find 1, and then that's what you're using to figure out how to factor
On a
it.
cubic. Who says we're limiting ourselves to cubics?
Okay. But I mean, we'll take it to a point where it's something that's factorable.
Yeah.
You don't have to continue with the synthetic division or the guessing.
That's
right?
correct. Yeah, you don't have to keep continuing. Okay, so that always helps if you write the problem down correctly. Now, what I will say here is, for those of you who like other rules to remember besides Descartes' rule of signs, okay? Let me give you one more rule here that can be helpful, but not super helpful.
Can I clarify that rule before we add 1?
Okay.
So is the Descartes rule of signs, the at most 2 positive or 0, and at most 1 negative or 0, is that we are strictly talking about cubics? X.
No, that's with all power functions.
All power functions.
All power, this works with all power functions.
So if we had x to the 7th, we would still only have.
X to the 7th, you're gonna have 7 zeros. Okay,
But at most.
now at most, okay, I could have, so ignoring, so I haven't made a problem. But at most, I'm gonna have at least 1 negative, right? Do you agree with that?
Yes. Well, no. Oh, at most.
No, let me think. Because you're gonna have an even number of positive roots, right? Oh, no, that doesn't make sense, never mind. But here's what I will say, The thing to remember about this is I could have, I'm gonna have a bunch of terms here. I could have at most 7 changes in sign, right? So I could have 7 or 5 or 3 or 1 or 0 positives. And I could also have 7 or 5 or 3 or 1 or 0 negatives. Okay? But the combination of this would be, let's say that I had, for example, let's say that I had 5 positive. How many negatives would at most would I have to have? 2. I'd have 2, -2 at most. This is at most,
Right.
Yeah.
okay? I could have fewer than 5,
Right.
and I could have 0 negatives,
Okay. That makes
Okay.
sense.
because we're going to include imaginary numbers in here. And that's what section 5 is, okay?
Are we going over this on the test tomorrow as well? Or are we doing this on the test?
Yeah. So that's why I wanted to make sure. So all of this works. Let me just see. The last rule that I wanted to give you, this is kind of helpful, but not super helpful. This is your upper and lower bounds theorem. And it says basically, if we divide P of X by X minus B with synthetic division, if the row contains no negative entries, then B is an upper bound. And likewise, if we divide P of X by X minus A using synthetic division, and the row alternates sign, then A is a lower bound. And so here's what I mean by that. And in fact, we probably, well, it's kind of hard to say here, but we know, let's go back to this example here, now that I've got it written right here, okay? So what I could have said was, let's say that I had picked 3 as my possible factor. Now we know 3 is not an answer here, right? Okay, but if I go 2, 1, -13, 6, if I do my thing here, here, I'll just do it really quick. 2 times 3 is 6, 7, 21, 8, 3 is 24, and this is 30. Okay, do you see that all of these are positive, 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 positive? Okay, you see that? Okay, so what it means is there's no sense trying +6 because these are all positive. Okay, so I could have eliminated 6 much earlier than I did. Okay, +6. That doesn't say anything for -6. Okay, now if I had picked
Because you already had the positive.
the
2,
-3 is a bound here. Now there's no reason to pick 4, but let's pick 4 for a minute. Let's pretend that 4 was a possible 0. Okay, essentially if I go plus, no, I'm going to go with a -4 here. Okay, so if I go plus, minus, plus, minus, do you see that these signs alternate every time? Okay, so in this case, -4 would be a lower bound, and so there would be no reason to check -6. So that's essentially what the upper and lower bounds theorem says. Okay, so this can help you if you get all positives. That's an upper bound. If your signs alternate every time, that's a lower bound. So then you don't have to try every one like we do in the first one. Yes.
So just to check my understanding, another way of saying that could be if they're alternating, it's a higher number than what you just tried. If it's all positive, it's a lower number than what you just tried.
That's right. That's exactly correct. Okay. So this can help you eliminate some of these zeros so we don't have to go through them. But always write the problem down correctly. That'll help a lot. Okay? Yes.
So, okay, never mind. Yeah, I answered my own question.
Okay. All right. So essentially, let me make sure, but I think as far as theory is concerned, I think we've covered everything in 3.4 and 3.5.
I thought we were doing imaginary numbers today
We
too.
are going to do imaginary numbers. I'm trying to decide. We've got about 20 minutes left, and so I wanted to make sure. So I'm going to do one more in section 3.4, and then I'm going to go to 3.5. All of the rules apply in 3.5 as they do with 3.4. So, okay. And I want to make sure we don't run out of time. I'm going to erase this. Is everybody okay with that? Okay. So let's do, because somebody said, "Oh, are we stopping at 3?" No, we're going to do a bunch. Okay. So let's say that I want you to factor, and I won't be so mean as I did at the first one. But hopefully I'll write it down this time. P of x equals 2x to the 5th plus 5x to the 4th minus 8x cubed minus 14x squared plus 6x plus 9. Okay? So the first question I want to do is I want to say list all possible zeros. Okay? Ethan, I think it must be your turn. So we need to find our P's and our Q's, right? What are my P's? Plus or minus 1, plus or minus 9, and plus or minus 3. Okay? What about my Q's? We'll stick with Ethan. Plus or minus 1, plus or minus 2. So all the possible zeros are, Cameron?
Oh, all possible zeros are plus or minus 1, plus or minus 2, plus or minus 3.
No, 2 is not 1.
Wait. Oh.
All of these over 1, right? Let's do those first.
So plus or minus 3. Plus or minus 9.
Okay, and now we're going to go put all of these over 2.
So then plus or minus 1/2, 3 seconds, and 9 seconds.
Okay, so if I gave you a question that said, can you list all the possible zeros, how many of you feel confident you'll get that right on the test tomorrow? Not you, Cameron?
No. Finding the zero.
Okay, well, I hope you get confident by tomorrow, okay? So those are all the possible zeros, okay? Now, what if I tried, so let's start finding one. Let's pick a 1, okay? Let's start with a nice number. And Andrew, it must be your turn.
Sick. So we need 2, 5, -8, -14, 6, and 9.
Now, before we do that, one of the things that we might want to do is, do we want to go through Descartes' rule of signs and figure out how many positives and negatives we might have?
Yeah.
Okay. Mallory, do you want to do that?
Yep.
Okay.
So there's no
So do I have a
change.
change in sign?
Nope.
So no change?
Yeah.
So one change,
One change. no
still one change,
Or one change.
two
So you have
changes. Now we've got 2
overall.
changes in
Yeah.
sign. Okay, so how many positives?
2 or 0.
2 or 0. Okay. Now let's figure out the negatives.
So since we have a total of 5 zeros overall, it's going to be 3 or 0?
3 or 1 or
Okay.
0, right? It always goes down an even number.
Okay.
Okay. Now, we didn't go through the P of negative x. How did we get on with the 3?
Oh, what I did, I just.
You
got
said
the-
2 and 3 is 5, right? Okay. Now, it might be 1 or 0. Three might not be too many. Do you understand why?
Because it's a max of 5, it doesn't have to be 5.
It's a maximum of 5. So really, in order to do this properly, I should figure out p of minus x, which is going to be, that's still going to be a negative, 2x to the 5th plus 5x to the 4th. I'm going to try to do this plus 8x cubed minus 14x squared
It'd be plus
minus
14.
6x plus 9. Say it again.
Wouldn't it be plus 14 and minus 9? Because you're changing the sign.
This is negative squared is
Oh, okay.
positive times negative is still negative, okay? I did that super fast. So as far as changes in sign, I've got one change, still one change, two changes, 2, 3, okay?
Wouldn't the 9 be negative? No.
No,
Oh, no, because it's an
nine's-
X, sorry,
no,
sorry.
Okay, so yes, 3 or 1, or 0.
So on the test tomorrow, are you gonna have us, like, is there gonna be a question, use Descartes, like?
I might,
Descartes' Okay.
but the reality is, this is what it's more useful for. You're gonna have 5 possible roots. Whether they're imaginary or not, you're gonna have 5 at most, okay? So, yeah, the first rule of Descartes' rule of signs is really easy because you don't have to do anything. The second one, if you want to be super correct, you might be able to lower that to a lower number than 3, okay? All right, so back to Andrew. Yes, before we go there.
So is that saying that you like have to have at least 3 or 1 or 0, like you can't have
That's
2? For like.
On this problem, I cannot have 2 negative zeros. That's
Okay,
correct.
so it has to be.
It's going to be 3 or 1 or 0. Okay? And actually, I could probably throw out the 0, right? It's going to be 3 or 1. It's going to have to cross somewhere. Okay? Andrew, now we can finish.
Drop the 2,
2,
2 times 1 is 2, 7, 7 times 1 is 7, negative 1, negative 1, 15, negative 15, negative 19, it's negative 9, and then negative 9, 0.
0. That worked out pretty well, right? Okay? All right, so we now know that x minus 1 is a factor, right? We're left with what, Andrew?
What's that?
What are we left with?
2x to the 5th, to the 4th, x to the 3rd, x squared, x.
Okay, so we're left with this. How we write it here? X minus 1. Okay? Now we can do this again. Has anything really changed? Not really. I still got a 9 here, so that doesn't change, and I still got a 2 here, so that doesn't change. So we're still going. Could 1 be a root again? Possibly, right? Okay? So, because I'm going to be I don't want to waste too much time on this. Let's try negative 1, because I want to have success, not failure on this. We saw enough failure already.
On the new equation, we're doing negative 1.
Okay, so we're going to try negative 1 with what's left down here. Whose turn is it? Take that, everybody. Niels, I haven't picked on you, have I? Maybe I did. Picked on you. Okay, so what am I doing synthetic division here?
So you're gonna do 2, 7, negative 1, negative 15, negative 9.
Okay,
Bring down the 2. 2 times negative 1 is negative 2. 5, negative 5, negative 6, 6, 9, negative 9, positive 9.
wow. It's great when a plan comes together, right? Okay, so now I know my factors are x minus 1, x plus 1, and I'm left with 2x cubed plus 7x squared minus x Sorry, I'm looking in the wrong place. 2x cubed plus 5x squared minus 6x minus 9.
So we still have 2 and 9.
Yeah, we still got 2 and 9, so nothing has changed here, right? Let's try -3. And I know I'm cheating, but I'm also worried about time. Spencer, I think it must be your turn.
So we're gonna look at the numbers of 2, 5, -6, and -9. Bring down the 2. It's gonna be -6. The remainder is -1. +3.
+3.
Remainder is -3. +9.
Oh, we're batting 1,000 today, must be living right. Okay, so now I've got x minus 1 times x plus 1 times what? What's the factor here?
X plus 3.
X plus 3. I'm left with 2x squared minus x minus 3, right? Is that factorable?
Yeah.
Okay. Now, by the way, is there anything I can eliminate now? I can eliminate the 9s, right? Anything to do with the 9. Okay. What does this factor into? 2x, x, 3, 1, minus plus, right? Okay. So I've got x plus 1 and x plus 1. So I'm going to factor this into x minus 1 times x plus 1 squared times x plus 3 times 2x minus 3. I have now factored that nasty looking one, right? And what does it look like? Kelly, oh, I haven't picked on you today. Can you graph that for me? Even though it's very low on the board? What does it look like?
So because it's a power function of 5, it's going to be starting low and ending high.
Starting low, ending high.
And then it's going to cross at +1.
+1.
And then it's going to touch at -1.
-1 it'll touch. Okay, we'll get there when we get there.
And then
Okay.
-3.
But that's got a multiplicity of 2. That's very good observation.
And then -3.
-3.
And +3 halves.
And +3 halves, which is about right here. Okay? So we're coming along here, we're getting to -3. What happens?
It's going to cross.
Cross, we're going to get to -1.
Touch. And then
Cross. We're going to get to +1.
-1 is a
backwards.
touch, +1.
-1 is a touch.
Oh, you're right, I said that wrong.
I was like, whoa, I'm almost
Yeah. Okay, -1 is a touch. We're going to get +1,
cross.
cross, and +1.5, cross. Okay? And there you are. Do you feel smarter today?
Not yet. So if we were to do this on the test, do we just have to plug in each one on every step? Or is there a way to know, like, I jumped to -3 at this point?
Yeah, it's all guess and check. Yeah. We did a lot of the guessing on the first one, so that's why I didn't want to keep guessing.
So that's
That's why I was
potentially like
cheating. But yeah,
20 times
potentially
longer.
this could be a sucky test.
Yeah.
Okay, just this one problem, right?
Can you make one thing?
Now let's talk about this for a second. How many negative zeros do I have? Got 3, right? Because this is a double root. Okay, 1, 2, 3. 2 positives. So that worked out. Okay? Good thing I picked on Niels before he left. Okay, so let's do another one. This time, let's do some imaginary ones. That'll be a lot of fun.
So it's just my money.
Now, let me ask you a question. If I had one imaginary, can I only have one imaginary root? No, if I've got one, I've got two, right? So we call that the conjugate pairs theorem. Conjugate pairs theorem. Okay? Every imaginary root has to have, so you're going to have a plus or minus I, for example, or a plus or minus 2I, for example. Conjugate pairs theorem. Okay? So let's do one that might not have real roots. How about oh, this is good. Okay, what if I said I want you to P of x equals 3x to the fifth plus 24x cubed plus 48x. And I said I wanted you to factor that. Angel, I've got faith in you. Okay? Can I factor out anything right off the bat? 3 and
3x.
an x. Okay? I'm left with
X to the fourth plus 8x squared plus 40 divided by 3.
just 16.
Yes.
Okay? Can I factor that? Without using the rational zero stuff.
X squared plus 4.
Yeah, I can factor that into x squared plus 4 squared. All right? Yeah, it is. Okay? And I've still got my 3x. Okay? So, we've got a little bit of a problem here. Is that factorable? Not with the real numbers.
Yeah, not with real numbers.
It is factorable with imaginary numbers.
So it's plus or minus 2.
So if I set this equal to 0,
Oh my gosh.
I've got x equals 0, right? Or I could say x squared plus 4 equals 0. Subtract 4. X squared equals minus 4.
Positive.
So x is going to equal the square root of negative 4, which is plus or minus 2i, because remember, it's always going to be plus or minus. Always has to come in pairs, conjugate pairs there. Okay? Now, how many possible zeros are there? I've got 5 possible zeros, right? I've got one real, and remember, I've got a multiplicity of 2 there. So how many zeros do I really have there?
2 to 3.
4.
Can you say it one more time?
How many imaginary zeros do I have? 2. Okay, you see 2 here, but there's also a multiplicity of 2 here, so there's actually 4. That's a big one, huh? Okay? Because these are double roots, basically.
Got it.
Okay? All right.
So if we're looking at imaginary possible zeros, it's going to reach the maximum.
It will reach the maximum, yes. So I've got one real, and I've got 4 imaginary. Okay? Now, according to Descartes' rule of signs, how many positive zeros would I have?
0.
There's no change in sign, right? 0 positives. How many negative zeros would I have? That would be negative 3x to the fifth minus 24x cubed minus 48. I would still have 0 negative zeros. Okay, so that might be the big clue. I ain't going to find any more.
They're going to ask us to graph that?
If I asked you to graph it, probably not, because all we know is it crosses here, but we don't know what else it looks like.
Okay, cool.
We'll save that for calculus. It could look something like this, but you don't know. All we know is it only crosses one time.
Okay.
Yes.
So I understand how you got the 2i out of finding zeros, but how did you get just the I out of there?
Okay, so the square root of -4 could be written as the square root of -1 times the square root of 4.
Okay.
What's the square root of 4? Plus or minus 2.
Square root of negative 1 I.
That's I.
Yeah, but then you up by the top, you said that you have a plus or minus I.
I've got so this is a factor with a multiplicity of 2, right?
Right.
So I've got this. You can think of that as it's a quadruple root. What's it? So plus. So here, let me say. If I factor, let me factor this way. Okay. So this could be factored into 3x times x plus 2i times x minus 2i times x plus 2i times x minus 2i. That probably makes it a lot more clear, right? Do you see that now? So I need 5 roots, or 5 zeros, 1, 2, 3, 4, 5.
Right.
So these are repeated twice, those are repeated twice.
So would that mean if the 2i gets repeated twice, or so of course positive 2i is repeated twice and negative 2i is repeated twice, does that mean you could split that in half and then just make it a plus or minus I? Does that?
No.
Because up on the top you have plus or minus I and plus or minus 2i.
Well, those are just examples. Those have nothing to do with this problem.
Okay, now makes
I
sense.
said basically you can't have an I without having a negative I. You can't have a 2i without having a negative 2i.
Okay, that makes
They always come in pairs.
sense. Yeah, I just thought maybe you got the 1i somehow.
No, I was just making that up. Let's do one more. This one's not too bad, I think. Okay. P of x equals x cubed minus 2x plus 4. And I say I want you to find all the zeros. Okay. X cubed minus 2x plus 4. Okay, how many positive zeros am I going to get? Change. I've got 2 changes in sign, so it's going to be 2 or 0 positive. Negative x cubed plus 2x plus 4. I'm going to have 1 negative, or no, I'm not going to have 0 negatives. I'll have at least 1 negative. Okay. So how would you factor this?
Is that a 4 plus 4?
That's a 4. We're going to have to find our p's and our q's, right? P's plus or minus 1, plus or minus 2, plus or minus 4. Q's are plus or minus 1. So really, those are my options. Okay? We're short on time. I'm going to take a negative 2. It's great when you can guess right on the first try. Sorry, it's not going to happen on the homework. Okay? I'm left with 1, 0.
Oh, yeah.
Oh, don't forget the 0. Negative 2 and 4, right?
Oh, the 0.
Ash, or Caitlin, I mean. I don't know.
Yeah, I was
I'm gonna
about
call
to
you
say, who's
Ashley.
that?
Caitlin,
Okay, so you bring down the 1,
1,
and then it's 1 times negative 2, so that's negative 2, and then it's positive 4, and that's 2, and then that's negative 4, and that's 0.
all right, so this becomes the factor,
So that's x plus 2.
and this
then
becomes,
That's x squared, and then negative 2x, and then just 2.
and that's not factorable.
It is, isn't it?
Yeah, it is.
Because there's the 2.
No, because of the signs.
Okay, you can try to factor it, it's not. So we're gonna have to use what now?
Imaginary number.
Quadratic formula.
Oh, sorry.
Negative b plus or minus the square root of b squared minus 4 times a times b all over 2 times a. So that's 2 plus or minus square root of 4 minus 8 over 2, which equals 2 plus or minus the square root of negative 4 over 2, which is 2 plus or minus 2i over 2, which is 1 plus or minus I. Okay, so your roots are at negative 2, 1 plus or minus I. That was good because we threw everything at you in that one, right?
Yeah.
It's going to be a fun test tomorrow, isn't it?
So,
Yeah, are you gonna give us extra time?
we're gonna review.
So we'll review for the first, I'll say 45 minutes. And I'll try very hard to get that review up, but just do the homework, it's good stuff.
Yeah, see ya.
It's the only way I remember.